Hi everyone, it's Orkan. Welcome to my channel. Today we are going to solve LeetCode minimum cost climbing stairs problem. So let's first take a look at the problem statement. The problem statement is that we are given an integer array cost where each element is the cost for each step on that staircase. Once you pay the cost, you can either climb one or two steps. So we can either start from the zero or we can start from the first index. We need to return the minimum cost to reach the top of the floor. So for example, in this case, we have three stairs, and the price for each one is 10, 15, and the 20. So we are starting from the first index. We can start either from zero and from two, so from zero or from one, and we are starting from one, and we are paying 15, making two steps, and we are reaching the end of the array. So the same with the other one. So we have 100, 100, 1, 1, 1, and so on. So in this case, we are either making one or two steps. So this is the best case scenario, best combination that we can make in order to reach the top. And the minimum amount that we are paying here is 6. All right, that's the problem statement. Let's see how we are going to solve this problem. All right, let's actually take this example, our second example, and work on it. So we have 1, 100, 1, 1, 1, 100, 1, 1, 100, and 1. Okay, so let's work on this example. So which approach we are going to use here? The approach we are going to use is dynamic programming. So what's that mean? The dynamic programming is when we are solving so we are breaking down a problem to sub-problems, and we are solving those sub-problems. Then we are using the solution that we have, the sub-problem that we have solved, in order to build up our solution. So let's take an example. I think that it will be more clear. For example, let's say that we are solving only this sub-problem. So what is the scenario that when we have only two elements? If only two elements, then we are just comparing that so which one is which value is lower, and we are taking that one. What if we have three elements? So what three elements we can arrive to this point, to this index, when from here and from here. So it means that whichever lower, so we are taking the comparing 1 and 100. So 1 is lower than 100. So we are taking that and adding the value of this index, of the last index. So what's that mean? We are taking the minimum of the cost I n minus, or let's say the I n minus 1 or cost n minus 2. So whichever is lower, plus cost of n. Okay, so in this case, the price of us, the cost of us to arriving to this index is equals to 2. So because we are paying this price, and since we are starting from here, it equals to 2. So we have solved this sub-problem. What if we have 4? So 4 values in our array. So in that case, so how we can get to this point? To this point, we can get either from here or from here. The price for getting from here is 101, and from here is 2 plus 1 is equals to 3. So then we solved this sub-problem. Now we are going to the next sub-problem. So how about this one? What's the price of coming to this point? To this point is either from this one, which is equals to 3. When we solve this sub-problem, So we know that the cost of us, the minimum cost of us to get here is 3, and the cost of us to get to this point is 2. 2 plus 2 is equals to 3, and 2 plus 1 is equals to 3, and 3 plus 1 is equals to 4, so we are taking 3. So now we are getting to the next index. Next index is like for this one, we it's regardless, right? Whatever we are, doesn't matter from which index we will, so we will get there. The price always will be 103. So okay, 103. So then we solved also this subproblem, and so on and so forth. So we are solving this our subproblem, and at the end we are just returning whatever is so whatever. After solving the last one, we are returning that whichever is lower, because at the time we can make one or two steps. So we can make either from here or from here. So we are comparing the value that is here, and we are taking the one that is lowest here, the one that is the lowest. So for example, in this case, let's just go up to the end. So 103, we are now we are taking this subproblem. 103, 3 plus we can get here from either from here or from here. So which means that 3 plus 1 is 4, and 103 plus 1 is 104. So we are taking 4. So the same is that if we get, now we also solve this subproblem. Let me take another color. Now we are here. So we can get here either from here or from here. So if we come from here, it means that the 4 plus 1 is equals to 5. Right? And 4 plus 1 equals to 5. And so how about this one? From to here, we can get either we can get from to 100, either we can get from here or from here. The lowest one we can get from here is 104, right? So 104, and the last one is that this one is how we can get here, either from here or from here. So from here we get from this index we get, and it equals to 6. So we are comparing, okay, which one is the lowest one at the end, this one or this one? 6 is lower than 104, and the 6 our response. So that's how we're gonna solve this problem. Again, it's a dynamic program, but a very basic version of it, meaning that we are chunking our problem to subproblems. We are solving our problem, our subproblem here. It's actually a very good problem to understand dynamic programming in general. Like we chunk that, we solve the problem, subproblem, then we are building it up based on the previous subproblem that we have already solved, and so on and so forth. And at the end, we are getting to the result in one pass. So meaning that our time complexity is n, which is linear. So that's it regarding to the problem. Let's go to the solution part. All right, first thing that we are gonna do, we are gonna check if the length is equals to 0, if the cost length is equals to 0, in that case, we are just gonna return 0. We are just gonna return 0. It's our first corner case. In another one, if the cost length is if the cost length is equals to 1, then in that case we are just returning the cost. Zero, the first element. If not, then we are going to our algorithm, which is pretty simple. So we are starting from the second element, and I is less than cost length and I plus plus. So what we do here, we are setting to our cost I element, right? So we are taking the minimum cost, so the math minimum, we are taking either the cost I minus 1 or cost I minus 2 and the minimum of it, and the plus cost I, right? Plus cost I. And that's it. After we exit this loop, we have to check the last elements. So we need to return, we can actually copy paste this one from here. Length, cost, length minus 1 and the length minus 2 and the length minus 2. Yeah, let me check. Okay, should be fine. Okay, great. It works as expected. Let's go over it one more time. So first we are checking the corner cases. If it equals to 0, if there is no element, then we are just returning 0. If it equals to 1, which is there's only one element, we are returning that element. If there is only 2 elements, we are going to the loop only if we have more than 2 elements. If it's only there's only 2 elements, then we are just returning whatever is the whichever is the minimum. If there is more than 2 elements, then in that case we are applying to our algorithm. So as I said, as we have seen in the explanation part, so if there is a 3 element, we are solving only that subproblem. So we can arrive to the third element either from the first one or from the second one. We are taking the first and second one and comparing whichever is the lowest. We are taking that element, adding our cost, adding our, let's say that the 3 elements, right? So we are comparing 1 and 2, taking whichever is the lowest, let's say 1, plus cost of the third element. And we are progressing in our algorithm. And so we are solving a subproblem, then we are we are building up our solution. And at the end, we are just comparing last 2 elements and returning the cost with the minimum value. All right, that's it for today. I hope you like my content. If you like it, please hit the like button and subscribe my channel. That's the only way how you can support me. See you next time. Bye.